All right, here is where 4.9 ties into Chapter 5 and why I don't cover Section 4.9, or I cover it with Chapter 5. So the evaluation theorem, which we're going to be learning the fundamental theorem of calculus in 5.4, and this is actually tying into part 2 of that fundamental theorem of calculus. Fundamental theorem of calculus really relates how derivatives and integrals, those processes, are related to each other. But the evaluation theorem says that if f, a function, is continuous on a closed interval from a to b, then the integral from a to b of f of x dx equals capital F of b minus f of a, where capital F is any antiderivative of f, so that is capital F prime would equal f. So therefore, what this says is if you have an integral, the way to evaluate an integral is to find the antiderivative of the expression or of the function, and then evaluate the antiderivative on the interval that you're given. So another way to write this is to find capital F of x, find what the antiderivative would be of little f of x. And then I usually write it just with a vertical line, so evaluating f of x from a to b. So that notation, this really means what's above. You're substituting in b, substituting in a, subtracting the two values, and that'll give you, bless you, the exact value of your integral. So just looking at some examples, I should also point out this is a definite integral, so there are definite integrals and there's indefinite integrals. Definite integrals will have limits of integration here. Okay, so definite integrals, we can evaluate. Your answer should be a number. And so if we look at number 1, this is actually the integral that we looked at first in 5.1. We looked at approximating it with rectangles. Here we can see we came up with the value of 1/3 in 5.1, but here you'll see why exactly it is 1/3. So if we have the integral from 0 to 1 of x squared dx, we can evaluate this by first finding an antiderivative of x squared. So what would the antiderivative of x squared be? Dylan? Yep, so 1/3 x cubed, and then you evaluate that from 0 to 1. Meaning, I substitute in 1, so 1/3 times 1 cubed would just be 1/3, minus, and then I substitute in 0, 1/3 times 0 cubed is 0, 1/3 minus 0 is 1/3, and that gives you the exact value. Dylan? You don't have to worry about a constant if your integral is definite because you have the interval that it's on. So when we go over indefinite integrals, you will need it. So definite integrals, because your answer is just a number, you don't have to worry about the constant. All right, does that make sense? So as long as you can find an antiderivative, then you're evaluating the antiderivative. So I guess number 2, why don't you work on number 2? I won't walk around for this, but work on number 2, see or get an answer, and then I'll just show it and see if we all came up with the same thing, or you can ask questions if you have questions. So I heard some of you ask this. Yes, you can use a calculator to evaluate. I'm just going to show you there is a specific way to let your calculator do the whole thing for you. So I'll show you that. But yes, for right now, if you're just evaluating something, you can use your calculator. You don't have to do all of that in your head. I can write you one. Where are you going? All right, I actually will walk around. I just want to make sure you all had a chance to answer it before I show it. I mean, you can start looking at the next ones too if you're waiting, but. Okay, so here I was just checking that you had an answer, not necessarily seeing exactly what all of your answers were. So it should have been negative 6.75. So the antiderivative is 1/4 x to the 4th minus 3x squared. Evaluate that from 0 to 3. When you substitute in 3, it's negative 6.75. When you substitute in 0, it's 0. Questions? Okay. Then for number 3, as you're looking at it, I know some of you are working ahead on this, which is great. For this expression, how would you find the antiderivative? Okay. Yes, rewrite it. So how did you do that? Okay, so you brought the u to the 3rd up to make it a negative exponent and then distributed it to the 4 plus u squared. So it would be 4u to the negative 3rd plus u to the negative 1st. All right, so then what would the antiderivative of 4u to the negative 3rd be? Negative 2u to the negative 2nd. And then what about u to the negative 1st? Yes, so u to the negative 1st is 1 over u. So natural log of the absolute value of u. And then this is evaluated from 1 to 2. I could even rewrite this. Try to leave your answers as exact. So that means because of the natural log in this antiderivative, you would have natural log in your answer rather than decimal approximation. So usually when you're working these out by hand, it's probably on a no calculator part of the test, and you're going to need the exact value anyway, not being able to substitute it into your calculator and get an approximation. So what I'm going to do, though, is rewrite this as negative 2 over u squared. All right, so then you substitute. This is where a common mistake, or where I see a common mistake happen. You substitute 2 into the entire thing first. So if I substitute in 2, I'm going to have negative 2 over 4, so negative 1/2, and then plus the natural log of the absolute value of 2. Since 2 is already positive, I can just write that as the natural log of 2. So if you have the absolute value bars, it's fine, but you don't need them. 2 is already positive. And then, so I would take that quantity and then subtract what I get if I substitute in 1. And I substitute in 1 to the entire thing. So negative 2 over 1 squared is just negative 2. And then I'd have plus natural log of the absolute value of 1 is just 1. Natural log of 1 is 0, yes. So this is really just 0. It's kind of gone there. So I have negative 1/2 minus negative 2, so negative 1/2 plus 2. And that would be 1/2 or 3/2. And then I still have plus the natural log of 2. So 3/2 are 1.5 plus the natural log of 2 would be the exact answer. So unless you're letting your calculator do the entire thing for you, try to leave your answers in exact form. Any questions on 3? Okay, and then for number 4, integral of 0 to 2 of 2x cubed minus 6x plus 3 over x squared plus 1 dx. So we need an antiderivative for this expression. What is the antiderivative of 2x cubed? Yes. And then minus antiderivative of 6x, be 3x squared. And then what about the 3 over x squared plus 1? Dylan? Close. 3 arctangent, yes, or 3 inverse tangent, yep. Okay, so don't forget this is like 3 times 1 over x squared plus 1, and that's the derivative of inverse tangent or arctangent. All right, so then if I substitute in 2, and again, here leaving your answer in exact form, you're going to have inverse tangent still in your answer. So let's see, 2 to the 4th power is 16. So this would be 6 or half times 16, so 8 minus 3 times 2 squared is 3 times 4, so 12, and then I'd have plus 3 inverse tangent of 2. So I have that entire quantity if I substitute in 2, and then I would subtract what I get if I substitute in 0. So I know 1/2 x to the 4th will be 0, 3x squared will be 0, 3 inverse tangent of 0. So here, inverse tangent of 2, that's not going to be any special angle. Remember, this would be the angle at which tangent is 2, but that's not any special angle from the unit circle. However, 0 is, so at what angle is tangent equal to 0? 0, again, inverse tangent is from negative pi halves to pi halves, so inverse tangent of 0 is just 0. So I really just have 8 minus 12, which is negative 4, plus 3 inverse tangent of 2 would be the exact answer. Any questions there? Am I okay to flip this over? Okay. Then number 5. This one, or example 5, says find the area under the cosine curve from 0 to b, and b is in between 0 and pi over 2. So this is kind of an application, area under a curve. What helps you find the area under a curve, or what is interpreted as area under a curve? An integral. So this question is really asking you to evaluate the integral from 0 to, actually it'd be 0 to b, yes. 0 to b, b is just in between 0 and pi halves. but the integral from 0 to b of cosine of x. And then remember when you write an integral to include the dx after the integral, that's part of the notation. Okay, so then evaluating this. Antiderivative of cosine. Just sine, yep. So sine of x evaluated from 0 to b, meaning then that would be sine of b minus sine of 0. Sine of b we don't know because b is fluctuating between 0 and pi over 2, but sine of 0 is just 0. So this is just sine of b. Okay, so don't forget the main application of derivatives was always the slope of the tangent line. Main application for integrals is area between a curve and the x-axis, or area under a curve. So always know if you're looking for an area under a curve, that's telling you to evaluate an integral. Okay, so those are definite integrals. Definite integrals, your answer should be a number, even though here we don't know b, but this would be a number. However, because we're using antiderivatives to actually evaluate integrals, then this notation, so just saying the integral of f of x dx with no limits of integration, is traditionally used for an antiderivative of f. And this is called an indefinite integral. Indefinite because it has no limits of integration. So this notation means capital F of x is equal to f of x. So this is really equal to the antiderivative. Okay, so if you see, or rather than on the quiz you had, rather than me saying find the antiderivative, I could just say find this integral, and it would be the same thing. So an integral is an antiderivative if it's not, doesn't have limits of integration. So difference between definite and indefinite. So this one is definite. There are limits of integration. Your answer is a number or a value. So when you have a definite integral, your answer should be a value. When you have an indefinite integral, your answer is a function or an expression, because you're finding the antiderivative, but you're still going to have the variable in your answer because you don't have limits of integration. And then I included on here just a couple of indefinite integral properties, and we've already discussed these a little bit, I think, with properties of integrals. But if you have the integral of a sum or difference of two functions, you can write that as the sum or difference of two different integrals. And then if you have the integral of a constant times a function, bless you, if it's helpful, you can pull the coefficient out front, find the antiderivative, and then just multiply it by the coefficient. So you are allowed to do that. So the examples here, find each general indefinite integral. So again, this just means the expression in the integral, you're finding the antiderivative. So let's see, antiderivative of 10x to the fourth. To x to the fifth. And then what about minus 2 secant squared x? Minus 2 tangent of x, yes. Secant squared x is the derivative of tangent of x. Now, this is what Dylan had asked about before. Because you don't have limits of integration, you are just finding the antiderivative, you have to include the plus c. So do not forget your plus c's. All right, I'd like you to do number 7. Evaluate that or find that indefinite integral. and then I'll show you how to evaluate integrals on your calculators. Remember, we do not have antiderivative rules for products or quotients at this point.
Oh.
X wasn't there.
Oh.
All right, so just double check. I think we're okay. Do not forget your constants if it's indefinite. And then I do have some practice there. They're all odds, just to make sure. I mean, this is a snapshot, but with the different antiderivative rules, just making sure you understand them. There's some problems towards the end that make you really interpret what you're trying to find. So those are good to look at. On your calculators, just so you know how to do this. So on a calculator part of the exam, if you are given, say, let's just look, I mean, we can look at 1 and 2. We'll look at 1 first. On the calculator part of the exam, what tends to happen is they want to see, do you know how to use your calculator to actually get the value? So they might give you an integral that you actually can't find the antiderivative for. So you cannot do it by hand. You have to use your calculator to do it. And it is easier on the 84s because of the kind of math type that's already in there. So if you go to math, just hit your math key, and then it's option 9. It should say FNINT, FN so it's integral. If you have an 84 or a newer calculator, this very, very nice notation comes up for you to just fill in. So you would just fill in, okay, I have the integral from 0 to 1 of my function is x squared, and then dx. So this is defining your variable. If you don't have an 84, I'll come by you and help you know how to type it in. And then you just hit enter. Okay, you get 0.3 repeating. That is 1/3. If you don't already know how to do this, changing a decimal to a fraction on these calculators, if you have this, I mean 0.3 repeating, knowing that's 1/3, that's pretty simple. But say you get a different decimal and you just want to see if it does work out to be a fraction. If you hit math, the very first option will change whatever you have in your calculator to a fraction. You just hit enter for number 1, enter again, 1/3. Okay, so you can change decimals to fractions, or if it doesn't change to a fraction, it probably means it can't be changed to a fraction. It's irrational. So you could test that out even with number 2. Just type it in, make sure you can get negative 6.75. So you have to know how to do it by hand, but you also have to know how to use your calculator. So right now I'd say work them out by hand, use your calculator to maybe check, make sure you can do it each way. And then let me know if you have questions.